Okay, we got this mocked up some more here. So we took out that case, we got this one in here. So this has the closer to get lifter blocks, but they're going the same angle as the motor, which is the biggest thing. So right now you can see how that one has to go out a little bit there, because I think that's just how it's rolling across there. Obviously this is going to put it about right here. This one here is pretty close. I don't think it's going to go exactly dead center, but it's pretty close to being dead center. This one over here, it's going slightly that way, so the cylinder needs to go that way, but it's close, because this is too close together here. Remember, this has a wider spread up here than this is. This is the one that's off, it needs to be that way. Okay, the other problem is, right now, as we got our height here, the angle of this is going downhill slightly from where it should be. But we have to because the bore is right there. There's not enough offset up here. This should be up here. So that's a problem, but there's no way you can put this together at this position. So if we jack this thing up, I have my adjustable lift now. So take this and put it up higher where the case would actually bolt in there at that point. That's about where the spigot, that's your minimum spigot thickness right there now in the case. You can see how these now are pointed downhill quite a bit. Whereas these ones here look like they're angled already, or is that just a illusion? I don't believe that. They were going straight. So we just didn't notice it as much. So it's going like that. Now these are made to be at an angle. This one here is not. So you have to take that up in the block. So the push rod doesn't care if there's an angle. Now me, I want to get these bolt holes in here. So I'd go up even higher. So you can trim the cylinder away a little bit, but you can't move the bolt holes too much. So that's about your minimum there, and have any kind of material in the case. Put it right there. So that's about where it would have to be that way. And now you're looking at your original push rod angle for this motor. This is laying on the fin cut and inside here. You see how now they line up pretty evenly in here. This one's a little bit lower. That one's pretty nice, because these are supposed to be at an angle too. So this is more like the correct relationship that we had, because remember they had to have bolts in here. Their lifter clearances too. I would guess they're probably up a little higher. You would think they'd be at least this high up here to make everything clear on their motor when they built the airplane motor. So that's the angle probably everything would appear. I don't have the rocker arms yet to put stuff in to see where they're at, but it's probably up about this height here. Obviously these would have to be made at an angle to do that, but that's not a major issue. You can put an angle wedge in here, because it's just a bolt-on cover. You make a wedge in here, tilt it up, it's in there. So, and the fact that they're off a little bit on the height, a little bit too close together. The further we go this way, the less that's a problem. Right now we're too much height, I think. We had a 6-inch case height on that motor, about 6 1/4, and I'm sure we're way above that now. Where's my 6 inches at? Center there, 6. Yeah, we're about 6 3/8. So that needs to come back this way an 1/8 of an inch. So it's not a 1/4. So that, once again, that won't be too bad, because we got this height built in already. Like I said, it's 6 inches from here to the crank, as I recall. Center of the crank to the deck height. Actually, it's probably more like 6 1/8 inch to here. So 6 inches at the top of this block, so an 1/8 would be a little bit further. Yeah, so it's pretty close. Maybe an 1/8 inch too tall, but we're close to what this one is. But we don't know where this is supposed to be either, because it's not done. It's just laying there right now. Alright, so that lines up pretty nicely, no big issue, and it'll work all right. I'm not a big fan of having a lifter in the block and not be repairable, so worst case I can sleeve them, I guess, and do what I want. We're limited to a small diameter lifter, but once again, I can put a big bush in there and open it up. I'll put a big automotive style lifter in that thing probably. So I do have some options there. That's one of the reasons I like this block here. I can modify the piss out of this block. You know, I can take these and open them up a lot bigger. I can make them from scratch. And go to a big automotive style lifter, which is a lot stronger. But this one here, I can do the same thing too also. So but at least it doesn't have the angle of this one going splayed off. You know, this one's going way off that angle. You know, even they're both going that way, whereas this one here, they're both going straight, which I do like. This one over here, obviously, they're way the hell out. They're single cam, what would you expect? Can't fix the problem. Okay, so I know this is what this is. Now, what I'm going to do is I'm going to take this out real quick and put the iron head case on that. And I don't remember if the iron head lifter blocks come out at an angle or they go in straight. That'd be another problem. So let's see. My guess is they probably come out at an angle. Okay, there's our iron head case. Easy enough to check. Put it in there and look at it. What a shocker. It's the same as the 4-speed Evo case. I am positively shocked by that situation. Harley did not change anything when they went to that motor. Oh, I can't believe it. Okay, so if we come off of here, we're straight with the block, and see the angle to the block is not 90. 90 is way over here. And obviously, that means there's a big gap there between the scale and the block. So these blocks have the same problem as that motor down there. So that means that motor, we have defective issues with that case. It don't work. The problem is I had to buy a case to figure this all out. Anybody want a case? At least it's not broken. Got some stud issues though. This case here is a freebie, so I didn't care about it. But it's not going to work either. So, oh, fire in the hole. So, as much as I hate modern motors, this looks like our best option. So, the 5-speed Evo case, which is in between these two here, because that's 4-speed, that's rubber mount, is the case is all cut out in here and there's no piston squirters in there. So this case is a better option. Alright, so it looks like the late rubber mount Harley case is the only way to go. Well, not the only way to go, but the best way to go at this point. Okay, let's see what happens when we put the big motor on here. So I'll just take this one off. Take the little baby motor over here, this one, and I'll stick it in here. It goes in there like that. Okay, how am I going to lay this out? Let's see here. No, it's adjustable lift over here. I can do this. I like that. Makes it easier. Let's see, this one had a 2x4 in here. Yep. That's it right there. And we're angled a little bit still. What do we hit over here? 2x4. Watch your foot. It might hurt when that hits you. go. Alright, what we gotta do to hold this up? Jam something in this corner over here. There we go. Alright. Slide all that forward. The advantage of this is I can pull it all the way to the deck now. Scale. 6 3/16. I like that. So that's about that is about the running height, what this motor would actually be. Okay. Relatively square. Now we need to go up a little higher. I like this adjustable case height, it makes it nice. Okay, right there would work. Let's see what we got here. Looks pretty nice. So we got a narrow push rod angle there, we got a narrow push rod angle up here, and it's just about dead straight, which is hard to beat. It's definitely way better than that one over there, obviously, because those are not even close to being the same. So this one's going about the same, straight in line. That's nice. I like that. It's lined up. The offset over here matches. We have it offset enough for the big bore. Could probably go a little bit more. Maybe that way just like another 1/8 or so, but it's good. The problem is our crank center line is off by about that much, which is not good. That would be not good for how it runs. Height-wise, we are right on the edge of our lifter block, so that's the height we would run it at. The angles here look like what they're made to be. Just see, it looks like it's almost perpendicular what that should be. If anything, it probably could go a little bit higher up. And that's too high, so that's too much. That's too low, so probably about right here is straight. Yeah, see, that looks pretty straight right there. So my guess is they ran this a little bit higher up yet. I don't need to go any more than this edge here than that, so I'm good at that number right there. We'd have to add about that much to our case height. About that much. What's that, about 1.5 inches, 1 3/4 inches? Probably 1.5 inches. 1.5 inches. So we have to add 1.5 inches to the case parting lip to get it to the center. So you're adding 3 inches to a stock case. I think that's what that means. Okay, so that would be, that's what that one mock up at. So that'd be pretty close. Everything lines up really, really nice. So that's a good combo. Now the other motor was not quite as sweet as that because it had the narrower, because this is wider than this one. This is narrower, so it works better. It just lines up perfectly with it, which is really nice. Now this one was pretty good. It just had a little bit of splay difference, but it was kicked over. This one here wasn't quite enough. We still need to come over a little bit. It was good. Now the problem with this is the crank center line is screwed up badly. So your crank center line should be lined up with the center of your motor. You want that to line up perfectly there. Obviously, you can see it's not anywhere near center. Crank center line is way over here. We're off by a couple inches. or at least 1.5 inches or something. Probably about 1.5 inches. Yeah, 1.25 inches. So that means the motor would not be physically happy. Things want to be on center, so that when you go up the center of the crank pin to the cylinder, all the way up the whole thing is in line. That's how this motor here is built. That's what you want to do. Now when you start moving the cylinders over, it'll affect the cam timing, the compression, the piston dwell will all change, how it comes up and changes around. It changes all the timing of all that. So the cam timing would be affected, the compression heights and ignition timing would be affected. A lot of things would be affected. Also the dynamics of how the piston and the rods go around would be really affected. So, but if you got to do that to get the big bore, then well, that's what you got to do. Now, the way of getting around some of this is I can change the angle of the case. Now with the iron head with the 4-cam motor, that's a lot more doable. So that means you take it and you cock this thing. There, yeah, I've got some room. So instead of being at 22.5 degrees, which is our 45-degree V angle, you take it and you go like that. See how we got a lot closer? So we change our V angle over here. Now, you also see the cylinder moved over a lot, so now we need to move the cylinder. We need to move the case back to where we started. So we're back on the inside the cylinder spigot there. And now, coming down the center of that, and between the center of the push rods. So now we're only off by that much. About 3/8 of an inch. Now that's a livable number. Now the bore works better too. Now how much of an angle change was that? I'm not sure. Quite a bit. So if you change the V angle by a few degrees, it makes a huge, huge difference on all these other numbers. So ideally you want to keep it as close to center you can. Now right now, my bore, I don't think I'm going down the center of my bore. I think my center of my bore is now over further. Right between the case to the end, about there. And where's that putting on the bore? We're only off by a couple hundred thou, and I can offset the piston and the wrist pin to do that. So whatever the V angle this is here, changed. Is kind of what we're looking at doing. I'd have to draw it up to see what it would be, but I don't know if I have an angle finder around here. Used to have one. Yeah. Where in the hell would that be these days? I haven't got a clue where anything is anymore. I used to have some tools like that in the shop, and I knew where they were. I'm going to go up here and see if there's anything laying around up here that looks like a compass. Nope. Yeah, there's nothing around here anymore. Yeah, beats the hell out of me. No more easy to find stuff. What do we got here I can use? Ah, there's one right there I could use, but doesn't have the numbers on it. But, ooh, at least it tells me what I got. No numbers, but it gives you a reference to what it is. Just guess the numbers, I guess. Do a measurement, who knows. Okay, so now, if I take this, come off of this case here and match that, I should have a number. Yeah, let me do that. Well, I won't have a number, but I have a reference point. I can kind of guess. Guessing's always better than nothing, right? whatever the hell that is. What is that angle? I don't know. But that's the angle we got it at. So we know this is 45 degree here. So we're going to change it by that much. So that's not a big change there. That's probably less than 10 degree difference. So instead of being 45 degrees, we bumped it to something different. Our S&S went to a 60 degree V twin motor to get more room for big bores. So if I had my guess, because they run bores like this, they run 5-inch bores in those big ass Buell race motors. I'm going to guess they probably, this is close to a 60 degree V. Just I don't know without measuring it. Well, I know it's not 60. Hell, I got a compass that's only 60. Okay, let's go see what we got. I don't have a compass. I got some triangles I made years ago that have numbers on them. Let me see. There's a compass right here. How can we incorporate that into this? Can't. I don't know how I would do that. Oh, okay, you hold it straight. Strictly an eyeball situation, so if you keep that vertical. Where's my zero at? Lost my zero. Have zero. Thought I had a zero. There's a zero right there. Okay, so if we make this straight to that, you come out to where the angle, the dangle's about the same. What's that? 30? About 35 degrees would be my guess. Be nice to have a compass. Guessing only gets you so far. All right. Okay, that's a 45 degree. This is 60 degree. It's 60 that way. It's 30 this way. This is 45. We're so close to a 45, it didn't really change much. I just don't have a way of telling what that is. Need more tools. Missing tools would be good. Alright, I'm going to guess it's probably only about 10 degrees extra, so that's a doable number. Yeah, if we went 10 degrees more, that would get that. The problem is you do that, you can't put in a Harley frame anymore. Because now the V is too wide. So, but that's what you got to do to make this thing line up with a bigger bore. Might be what we have to do. I know with the ignition system I can cheat 5 degrees on a point style, you know, regular cone style ignition system. I can cheat and make it work. 5 degrees. I think I got up to an 8 in ignition modules that you can go. So I can cheat a little bit, but I can't go more than that. Alright, so if we cheat a little bit, that'll help that that angle a little bit. It looks like if we raise the cylinders, going to get close to our oil filter here. Boss. Well, obviously we can't put a filter in there, that'll have to be whacked off. So this looks like the best case to use for now. which is really not what I want to do, but oh well. That's what the mock-up is for. It tells you the difference in parts. And this thing's heavy. Now, what I want to know is how weak this thing is. Okay, now, what was going on the inside of this case? Alright, so this case here is solid. See, it's solid all the way down. Okay, so the thickness of the case is straight all the way. So it's only undercut right through here, and then it's back thick again right here. Now these bearings are probably about 1/2 inch total thickness. The case is probably about a 1/2 inch thick through here, maybe 5/8. Okay, this one over here, these bushes are 5/8 thick. This case is solid that height, but then they whack it all out under here, which is bad. And they whack it out for the insert for that. You go on this side and you see that 5/8 thickness here. Well, that's the boss. It sticks up a long ways from this surface. So the actual thickness of this case is probably only less than 1/4 inch. Are the bushings flat? No, the bushings are on bosses too. See, everything's on a boss. Damn thing's probably only about 1/8 inch thick in the middle. So these cases are very, very weak. Which means when you start beating on them, they're going to break. I knew the late stuff was going to be thin, and these are definitely thin as hell. Now they got a lot of bossing in there, but that doesn't take away the fact there's no metal in there. There's a hole right there, but what's that hole? That hole's not anywhere we can use it. So if you just drill a hole right through there, you'll see how thick it is. I bet you it's pretty stinking thin. I'm going to put my fingers in there. It feels like about 1/4 inch thick. If I had to guess, I'd say 1/4 inch thick is all that is, which is not much to work with. Definitely way thinner than I like versus this thing here. It's thick. Oh yeah, it's like that. It's thick in there. But I don't like the valve angles. See, I like the idea of this case, but I didn't know about the angle issue. Alright, well there you go. This is my number 2 case, number 1 case, and that's definitely my number 3. So, too bad I don't have these lifter blocks in the right spot. It'd be so much better if they were. Yeah, I could probably change them and make new lifter blocks and move them. It'd be a lot of work. These ones over here, I just don't know how long the case will live before it broke. And you definitely don't have much room and much material in it to put a bigger main bearing in there. It's just there's nothing. Typical late Harley, there's no metal in anything. So this thing here, you got a lot of thickness in here. You got room to put a big ass bearing in there. This is the same bearing I run on my race bike. I cut out and put a big bearing in this thing. There's a boss in here. There's room for the big bearing, which is what this motor needs. The problem is this one here, there's no material in here for doing that. I can go in there and weld a bunch of metal in here, I guess, and make it bigger. It looks like it's the same height here as this one, so it's probably the same height on this side. Yeah. The case is probably about the same thickness overall in the middle, as long as you can get off this boss. The problem is the thickness of that boss. Oop. I can't see. It's up to about 2. It's about 1 3/4. It's about the same. So yeah, I could probably cut it out and put a bigger bearing in here, which is a plus. It's just the case they're just so damn thin. But Oh well, it looks like that lake case is the one to go with, so yeah, I hate doing that crap, but oh well, it is what it is. Alright, there's the mock-up for that.